All right. Say you've got something that looks like this, right? And I've got three angles I've created, angles 1, 2, and 3, created by these intersecting lines. All right? So I want to do the whole proof start to finish. I'm going to take my time. I'm going to go step by step. And remember, your responsibility is to be able to fill in the justifications as I do the initial statements. No oblique asymptotes at this level. There should be. Really, there should be. But I'm not going to hold you accountable for it yet. Sorry, random side question there. Not really random, it's a pre-calc side question. Back to the proof. Now, I want to do the proof start to finish. You should be able to fill in the justification column as I go along. If I tell you the next step, you should also always be, if I tell you what the justification will be, you should have been able to tell me the step that would have filled it. Here's what we're going to do. We are going to take statements and reasons. We're going to prove that angle 1 is congruent to 3. We're going to prove the vertical angle theorem together right now, right here, on live internet TV. Now, I want to talk about the diagram as my given. Okay, there we go. Now I know how far over I can write. Actually, I'm going to scoot. Double check my monitor. Okay, good. Everybody's looking good. Everyone's fitting on camera. There we go. Now, from the picture, angle 1 and angle 2 are a linear pair. Angle 2 and angle 3 are a linear pair. That's what the picture looks like. So that would be definition of linear pair. Okay? That's what we're looking at. Linear pairs. Now, what do I know about linear pairs? Think about what I know. I know one rule tells me that angle 1 and angle 2 are supplementary. Angle 2 and angle 3 are supplementary. What rule tells me that if I'm going to take linear pair, that means I've got supplementary angles. That would be the linear pair theorem. Now, we could wrap this proof up in one step, but I'm going to go all the way. Take it all the way to the bottom of the line, because I want to get as many ideas in here as I can get, because I really want to hit all the rules you have to know. So let's go with the next step. I just said angle 1 and angle 2 are supplementary. What do I know about them? Well, we talked about the idea that angle 1 plus angle 2 equals 180. Angle 2 plus angle 3 equals 180. Now, I just said these angles were supplementary. So think about what rules lead me to the idea that if they are supplementary, then they add to 180. What leaps to mind is the definition of supplementary, right? So I've got that. Now, why I like this proof. Look at all these rules we're using that we have to know for tomorrow. I have one idea here equals 180. I've got one idea here, 180 equals a third idea. So now I want to write this statement. Measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3. What rules let me do something like that? Now again, I took two equations, two steps, and I mashed them into one. Whenever I'm doing that, I'm taking equations, equalities, and I make them one statement. There's really only one thing going on there. That's got to be either substitution or transitive. When I'm blending two ideas into one third complex idea that yanks out that middleman, that's a transitive. So my justification, transitive, property of equality. almost there. Now, the next step in the proof, I'll give you the step, you think about the justification. The step says on my page, measure of angle 1 equals measure of angle 3. That looks like a 4. Let me clean that up. There we go. So measure of angle 1 equals a measure of angle 3. Now, if you're not sure what happened, look at the step before, reflect, think about what's changed. Looks the same. The purple and the blue are identical, except I've removed an angle 2 from each side. Since I've removed it, that would be the subtraction property of equality. When you subtract, remove from both sides of the equal sign, subtraction property of equality. And now my last step in this particular proof is going to be that angle 1 is congruent to angle 3. Now, your challenge, again, like I've been saying, maybe you're not following what I'm doing next stepwise. Remember, the goal is that you can fill in this reasons column way over here. The statements are good. It's those reasons we need to make sure we've got. What rule says that if two angles are equal in measure, they are congruent? We know that. That's the definition of congruent. And that is what I did set out to prove in this particular proof here as part of this review. Remember, our goal in this particular review was to focus exclusively on the reasons columns. To get all of these guys over here on the other side of this line. The statements I gave, you give me the justifications. Now, it's possible we have a rule, a theorem we've studied, that says 1 and 2 are supplementary, 2 and 3 are supplementary, therefore 1 is congruent to 3. It's called the congruent supplements theorem. That's over here, remember? The congruent supplements theorem? We could have done the proof in less steps if we used that theorem. But I did all the extra steps because I wanted to show you everything at work. We've got definition of linear pair theorem. And again, you're always looking up. You're looking back a step and saying, where can I go from here? And then you're asking, what rule connects those two ideas? And there you have it. And it's 8:30. So let me go ahead. I'm going to save the recording of that for later reference.